Significant figures are the digits in a measured number. In this video, I'm going to talk about what significant figures are. If you're looking for a video on how to count significant figures or how to multiply or divide with significant figures, that will be in my next two videos. That kind of information will not be in this particular video. So let's start by talking about what is meant by the term measured number. A measured number is one that we get from some sort of measuring device. We need some sort of instrument or a piece of equipment, and we will actually measure the quantity. So some examples of measured numbers would be a mass, or weight as we often call it, that we get from a balance, or a length that we would get from a ruler. That is a hard word to spell while I'm talking. Or a temperature that we would get from a thermometer. So something along those lines, or a volume that we would get from some sort of volume measuring device. The other type of number, a non-measured number, is called a counted number. And a counted number is exactly what you think it is. It's a number that you obtain by counting. So you don't use some sort of instrument to determine this number. You just literally count the quantity. This is always going to be representing a quantity of objects or whatever that we're talking about. So examples of counted numbers would be something like how many people live in your house, or how many grapes you just ate, how many legs on your dog, things like that. So we wouldn't need to use some sort of piece of equipment to determine how many legs are on your dog. We would just look at the dog and count 1, 2, 3, hopefully 4. So significant figures apply only to the digits in a measured number, and they are specifically all of the digits that are known with certainty. So that means that all of the digits that we can confidently read looking at our measuring device. And I've got two examples of measuring devices that we're going to use. And this first one, this is called a graduated cylinder, and this is used to measure out volumes of a liquid. And then this is just simply a ruler that we would use to measure length. So let's talk about the scale on this graduated cylinder. This is probably in milliliters because that's common. And on this graduated cylinder, we have increments that represent the 1 milliliter marking, 1 milliliter, 2 milliliter, 3 milliliter, and then we also have an increment that measures the 0.5 milliliter. So let's put some liquid into this graduated cylinder. Let's fill it up a little bit. And when we put liquids into our measuring devices, they don't have a flat surface like what I've drawn here. They have kind of a rounded surface like this. And so I'm going to round that surface to try to make it look realistic. So there I've put some liquid into this graduated cylinder. And so let's report and record the volume of liquid that's in this graduated cylinder. Now, before we do that, we need to talk about a little bit about this curved surface of the liquid. This is referred to as the meniscus. When you're reading the volume of a liquid, you always want to read at the low point. You don't want to read up here at one of the high points. You want to read down here at the low point. So this right here represents the actual volume of our liquid. I'm going to just kind of mark that off like that. So that's our volume of our liquid. And when we look at the scale on the graduated cylinder, we can say that we know for sure there are at least 2 milliliters inside this graduated cylinder, we're certain that there are at least 2 milliliters. We also can say with certainty that the volume is somewhere in between 2 and 2.5. We know that it's not 2.0 because that would be down here. And we also know that it's not 2.5 because that would be up here. So it's somewhere in the middle of this. We can actually take a pretty good guess about where this volume is in the range between 2 and 2.5. I'm going to say, for me personally, I'm going to say that this looks like it's about 2.3. That last digit, the 0.3, is not something that I know with certainty, but rather something that I estimated. And that estimation is an important part of a significant figure. So the significant figures are all of the digits that we know with certainty plus one estimated digit. In the case of my 2.3 milliliter, I know the 2 with certainty, and I estimated the 0.3 part. The estimation that you make is always going to depend on the actual scale that you're using. So if we had a scale that had more markings on it, we would probably be able to be confident. We would be able to say with certainty that it was a 2.3, and we would want to estimate something in the hundredths place instead. So let's take a look at the ruler and let's see how that might work, because as you can see, this ruler has more increments on it. So let's put an object underneath the ruler. I'm just going to draw a line, and we will estimate the length of that line from our ruler. Actually, I don't like that line. Let's do this line. So looking at our ruler, again, we can say with certainty that it is at least 1 centimeter. This is probably centimeters. So we know for sure that it's at least 1. It's not 2. And we know from our increments, this is 1.5, 1.6, 0.7, 0.8, 0.9. So it is more than 1.9. Let me draw a line here. I made a really curvy line there. We know for sure, we're certain that this pink line that I made is somewhere in between 1.9 and 2 centimeters in length. So I know that it's at least 1.9 centimeters. Both of those are digits that I know with certainty. And now I'm going to estimate where that line falls in between the 1.9 and 2.0 position. It looks like it's about halfway, so I'm going to say that this is 1.95 centimeters. And again, the 1 and the 0.9, the 1.9, those are digits that I know for sure because the increments on my measuring device showed me that I had at least 1.9 in length, but not all the way to 2.0. So I know for sure that it's 1.9 something. And then that 0.5, that is my 1 estimated digit. And so that describes, hopefully clears up for you, what the significant figures in a measured number represent. The last digit of a number, a measured number, is always an estimated number, and all of the other digits are always known numbers, but all of them are always significant figures.